Hi, I'm Carrie with J-Edge Anchor Systems, and I've got with me Matt Gorney with JEI Structural Engineering, and he's going to show you some really cool footage of the J-Edge Anchor configuration.
Thanks, Carrie. I'd love to show the Trimble model provided by KC Structural Steel. Let me go ahead and jump into it. So this is Trimble Connect, a program that they've modeled all the structural steel for this particular project in. And I'm using it to coordinate and run the engineering calculations for the J-Edge anchor system, which you can see is going to be used to support all of our glazing on the exterior of the building. Oh, bear with me here. This is the J-Edge. You can see here on the edge of the building. It's attached to our spandrel beams. With this system, you've got a continuous channel. You have an extruded steel piece. So you have straight steel down your entire length of your building with a channel built into it. So we have basically infinite amount of lateral tolerance for the curtain wall systems. And so we can see at the corner, you can see a little bit better what the actual profile looks like. And so that's the J-Edge right there. So essentially that's your channel. This is an extruded steel piece that we can attach throughout the entire all your spandrel conditions around the building. And so this one, you can kind of see here, it's quite a bit of glass. And so we have the J-Edge on every floor line. And we have different conditions for how the J-Edge is being attached, which is why I'm jumping into this model essentially as the engineer designing the J-Edge. So this is one condition. This is a quote unquote good condition structurally where our J-Edge is resting fairly directly on top of our spandrel beam. And so essentially they would come in the field and weld the J-Edge on this back side directly to the spandrel beam, and then they would add the decking, and the decking would run across our beams and run right up to the J-Edge. You'd add your slab reinforcement and pour your slab in, and this is your pour stop. And so we've got some kickers on this one. They're just kind of there for some additional support. Another condition where the kickers are going to become, and here's another one right next to it, this edge of the building sitting directly on the spandrel beam. So that's a good condition. And that's even closer to the outboard edge of the J-Edge. And so we decided there was no kickers needed on that one. Let me jump into a different situation where our slab needs to cantilever out past our spandrel beam. And for those conditions, we have those same angles or kickers. Those are going to be welded directly to the spandrel beam, and they're actually what's used to support our J-Edge or our pour stop anchor. And that's where I come in as the engineer of the J-Edge to make sure that, bear with me here, to make sure that we've spaced these accordingly. Because with this curtain wall system, we're going to have wind load and dead load supported. And again, we want to have that nice ability to have that infinite tolerance left and right. So those anchors could essentially occur anywhere along this. And we could have two mullions that hit within one of these spans. And so those are the things that I have to essentially look for and make sure that that load's accounted for, and that our spandrel beam, our pour stop, the J-Edge, can span between our supports. So yeah, this was just a really good 3D model of what's going on here. So that's that condition. Let me show you one that's even further out there, just to kind of give you an idea of the ability that we have to accommodate different conditions. So this one is an even further cantilever. So I think the typical cantilevers are somewhere inside of 2 foot. So this must be a little bit longer than 2 foot. So we needed more than just the angle to support it. We had to draw a kicker back down into the spandrel beam. And all of this essentially is already done with your typical pour stop anchor, with your just bent steel plate. You're always going to have all the support structure here. The reason why the J edge is better than a typical pour stop anchor is because when you're done, you have all that variability left and right, and you have a nice clean edge. This model is, obviously perfect, but that's pretty darn close to what you're probably going to get with the J edge because it's an extruded piece. So typical pour stop anchors, we've heard of, I've worked on projects where the variability is in and out of the building up to an inch. Your tolerance is going to be, and that's talking about how much it's waving left to right on that bent piece. The tolerance of this is going to be much less than that. So it's going to be where you need it to be.